Okay, at this point we have seen how to solve systems of equations using our graphing calculators and looking at graphs by hand and on our calculators. And there are definitely some disadvantages with using some of those methods. So that brings us to section 3.2, solving systems algebraically. And there are two algebraic methods to solve systems of equations. The first method is substitution. And our second method is elimination. In example 1a here, we are going to look at an example of substitution and where situations where substitution might be a good way to go. So example 1a. Solving a system by substitution. And here's my system of equations. I have x plus 3y equals 5, and negative 2x minus 4y equals negative 5. Okay, when I'm trying to figure out what strategy to use to solve a system of equations, substitution is really good if you can easily get a variable by itself. Or at best if you can easily isolate a variable. And that can be in either one of our equations. We just have to be able to easily isolate a variable in one equation. So looking at my top equation here, I can easily get x by itself. Okay. I can get x by itself by subtracting 3y from both sides. So x equals 5 minus 3y. And again, I just subtracted 3y from both sides here. Okay. Once you get a variable by itself, then we take this 5 minus 3y and plug it in for x in my other equation. So I'll grab another color here. 5 minus 3y can go in, substitute it in for x in our other equation. So I would take negative 2, and then where I saw the x, I'm going to write 5 minus 3y minus 4y equals negative 5. And now I really just have an equation with one variable. I can distribute this. Negative 10 plus 6y minus 4y equals negative 5. Combine my like terms. Negative 10 plus 2y equals negative 5. Add 10 to both sides. I get 2y equals positive 5. And y equals 5 over 2. Alright, so I got y equals 5 over 2. Remember though that a solution to a system of equations is an ordered pair, so I need the x coordinate that goes with as well. Now that I know the y though, I can take this y and plug it in to either one of my equations. And just noticing that I have a denominator with or I have a fraction with denominator of 2, that kind of tells me, hey, this bottom equation is probably going to be an easier place to put that in. So I will do that again in another color. Plug this in now. Plug into either equation. And I'll do that up here. And that gives me negative 2x minus 4 times y was 5 halves equals negative 5. Negative 4 times 5 halves. Well, 4 times 5 is 20, divided by 2 is 10. Add 10 to both sides. And divide by negative 2. So x is negative 5 halves. And that gives me my ordered pair, x, y, negative 5 halves, positive 5 halves. That's my answer.